Hi, welcome to Math with Mrs. Lehman. I'm here with my fourth period class. Say hello, everyone. Hi! All right. They're extra loud and saying hello. Today we are going to talk about the least common... No, we're not. We're skipping that. Didn't clear the page. Please hold. All right, sorry for the technical difficulties. Maybe it's just my difficulties. But anyway, today we're learning about the greatest common factor. So our lesson objectives today are, who can read one of the lesson objectives for me? Dylan, would you read the first one, please?
I can define the factor.
Okay, very good. Trisha, what's our second one?
I can find the greatest common factor.
Very good. And that is it. All right. So the first thing that we're going to do is talk about what is a factor. Does anyone have an idea of what a factor is before we start talking about them? Jade's willing to venture a guess. That's actually the product, but a factor.
Problem, but it's not. It's a number in the multiplication problem.
Very good. So, well said, Jade. It's actually one of the numbers we multiply to get a product. So let's define that up here at the top. So everybody's on page 34. It's 30. Oh, I'm sorry. It's page 30. All right. This lesson's broken up into 2 days, so page 34 is where the second part starts. So page 30. Right? The top looks very similar. So we are going to define a factor. So a factor is a number that multiplies with another number to get a product. All right, so when we're talking about factors, we're talking about, the numbers that we use to multiply. So for example, I can multiply 2 times 3 and get the product of 6, right? So 2 and 3 are factors of 6. It's a number that goes into the 6. Okay? All right, so now what we're going to do is look at the greatest common factor of 2 whole numbers. So if we're given 2 numbers, you may be asked to find the greatest common factor. So if we were to break those numbers down into what we could multiply to get those numbers, which numbers would they have in common, and then which of those common numbers, if there are multiples, right, is the biggest number. So we'll do some examples and then it won't seem as confusing. All right, so the first thing we're going to do is break up 12, all right? And we're going to start by listing the factors. So we're going to list the factors. If everybody could write that down on the side. List the factors of each number. And 2, we'll get to step 2 in a minute. So we have the number 12. Let's think of all of the things we can multiply to get 12. Who knows the most basic one? I got to call on Jasmine because she's answered like 35 questions. No, just say the easiest one.
6.
Oh, okay. 6 times what?
2.
2. Okay, that's an easy one.
Or 2 times
2 times 6, okay. Does anyone know a different math fact that would give us 12? 2 times 6.
4 times 3.
4 times 3, and
3 times 4.
3 times 4, okay. So 3 and 4 are both factors, right? 2 and 6 are both factors.
12 times 1.
12 times 1, very good. So we're going to list the factors of each number. We should add in order. So we're going to start with our lowest number. So our lowest factor of 12 was 1, right? And it was 1 times 12. All right, and then we said 2 times 6. So you're kind of writing these down as factor pairs, right? So 2 times 6, and then what would the next one be? 3 times 4, all right? So now you'll notice it goes from 1 to 2 to 3, 4. Is 12 divisible by 5? No, so we're not going to have anything there. And it kind of goes in a U, right? It goes right around like that. So if we were to list them out, it would be 1, 2, 3, 4, 6, 12. Does that make sense? If you're unsure if you've missed any, you can always look at the gaps between these numbers and see if there's anything that you missed. All right, let's look at 18 now. What would be the most basic way to say 18? It'd be something times something. Trisha?
8 times 2.
8 times 2 is 16. All right, so 9 times 2. Okay, so you're thinking of the 9 times 2. Even easier than 9 times 2. Someone called on LJ, yeah? LJ.
6 times 3.
6 times 3. All right, that's good too. What's another one?
1 times 18.
1 times 18. Can we take any number and multiply it by 1?
Yeah.
Yeah, so 1 times 18. Notice we have 1 times 12 up here. Will 1 be a factor of every number? Yes, right? Even 0, right? 1 times 0 is, excuse me, 0. So 1 is like a universal factor. It goes into every single number. All right? Every number is divisible by 1. Yes. Oh, okay. So what would the next one be, Madison?
2 times 9.
2 times 9. Very good. So 2 times 9. And we said the other one. What was the other one, everybody?
3 times 6.
Very good. All right. So we're going to check. Does 4 go into it? No. 5. It doesn't end in a 5 or 0, so no. And 6 we already have written, right? So in order, the factors are 1, 2, 3, 6, 9, 18. Right? Everybody understanding that all right? Okay, now these are pretty easy examples because they're lower numbers. On your homework tonight and in reality, you're going to have bigger numbers, so you're going to have to know this process even though you're looking at this going, well, that's easy. So our next step, step 2, is we are going to circle all common factors. So what is a number that is in both lists? What is a number that's in both lists? Katie, what's 1?
1.
1. That's in every list, right? So 1. Everyone circle 1. What other numbers do they have in common as far as factors? Jasmine.
6.
6. Very good. What else? Jade.
3.
Very good. 3. So we're circling that in both. And the last one that we see is 2. Very good. Okay, so we have all the common factors circled. Right? Now we're looking for the greatest common factor. So we are going to put a triangle around the greatest. We're going to call it the the greatest. And then we're going to put in parentheses the GCF, the greatest. That came out terribly. Let me erase that. Okay. Greatest common factor. That's really skippy. That's weird. Did you notice that? This thing's junking out on me. All right. Anyway, so put a triangle around the greatest common factor. So out of all of those numbers, which is the greatest? Mario. I had to say it like that.
6.
6. Does everybody agree? 6 is the biggest number they have in common. Yes. So we're going to put a triangle around that. Now, as much as New York State tells us that we should put this triangle around that and do all this stuff, that is not like a universal math symbol for greatest common factor or anything like that. It's just a way of showing that they have all of these common factors, but the greatest of all of the common factors is 6, and we kind of mark that out with a triangle. What you need to do is actually clarify that the greatest common factor, nicknamed GCF, is, so the GCF of 12 and 18 is 6. Right? We really just want to be very clear that it is 6, even though you have a lovely triangle around that. Right? Any questions on that? You guys want to try some on your own? You're like, I guess. Since we're in math class, we probably have to. All right, so if you guys could flip to page 37. There are some some lines on that page. Oh, please hold. So we are on page 37 where we have some blank lines, and the kids are going to find the GCF, or the greatest common factor, of 15 and 20. Now some kids are looking at this and saying, Mrs. Lehman, I already know what it is, right? Who thinks, oh, this is so simple? Yeah. Well, I'm glad you feel that way. However, these numbers are going to get bigger. So we're going to practice with the easier examples so you can build up the ability to solve them independently and know the steps and everything. But then when you're on your own and numbers are more difficult, you have something to go off of. Does that make sense? Kind of. All right. So now, personally, you can do it any way you want, but I'm thinking this T-chart that Mrs. Britt showed the other classes is a little bit easier because with those boxes, you don't know exactly how many factors there are going to be, right? So if we flip back, which you don't have to, but I will, if you look, these happen to have 6 in that beautiful, box work, whatever, but, like, honestly, there are many numbers that have plenty more than 6 factors, and then there are some that have way less than 6 factors. So anyway, 15. What should we always start with? 1 times 15. All right, what's another one? 3 times 5. Yep. Notice 1 times 15 equals 15. 3 times 5 equals 15. 2. Why will 2 not work?
Because 15 is an odd number.
Very good. So it's not divisible by 2, right? Nice job, Caleb. We're talking about whole numbers, though, okay? No decimals. Very good question. We are only dealing with whole numbers, okay? How about 20? 1 times 20. Everyone should get that one, right? All right. 2 times 10. What about 3? Will that work? How about 4? 4 times 5. So you're done when they're only like 1 apart, right? Because there is no whole number between 4 and 5 to even test. So we have 1, 2, 4, 5, 10, and 20. Let's circle the common factors. So what should we circle? Jasmine? 1. And what's the other one, Caleb? 5. Very good. And just double check. Are there any more? No. So what's the GCF? Yep, so that's right. The GCF of 15 and 20 is 5. Right, we're going to actually, let's add another one. The next set we'll do 6 and 18. Why don't you guys do this one on your own? 6 and 18, find the GCF. Look who's back. Becca again, Mrs. Lehman. You should see the cringy faces that the kids have right now. Sorry, kids, you're stuck with me. And anyone watching can feel free to push stop, go to the next video, go to another suggested video. But if you're enjoying these cringy, terrible things that I say, then please continue to like and subscribe Math with Mrs. Lehman. And if you have terrible comments, I've turned off the comments. But, maybe I'll turn them back on when I have decided that people can be nice. But in the meantime, I don't care. Anyway, so what are the factors of 6? I'm coming back to the back of the room to speak with Mr. Zach. Zach, what are the factors of 6?
1 and 6.
Very good. 1 and 6 and
2 and 3.
very good. So I'm going to write that down. So 1, 6, 2, 3. Nicely done. Are we missing any? Nope. Right, Dylan, what are the factors of 18?
1 times 18, 2 times 9, and 3 times 6.
You got it. So 1 times 18, 2 times 9, and 3 times 6. All right, so circle the common ones. Which ones are common, Katie?
1s, 2s, 3s, and 6s.
Holy cow. 4 factors. All right, so we don't care about all the factors. In this case, we care about the GCF. So what is the GCF, everybody? 6. So we're going to write the GCF of 6 and 18 is 6. So sometimes the smaller number actually goes right into the bigger number. And you're like, why would I waste all this time, Mrs. Lehman? This is for the birds. And I'm going to say, but kids, I'm teaching you the process so that you know how to do this when you have more difficult problems, all right? Does anyone have any ideas where we would use the GCF? Why in the world would we teach you this nonsense? You're not going to use it in the grocery store probably, would you? I don't know. Math teachers are always like, you're going to use this every day of your life. Yeah, probably not, but anytime you're working with...
Because New York State says you had to.
Good one, Katie. Actually, this was before those days. Okay, so we'll talk about this more in the next class. That was really funny. But if you had the fraction 6/18, right, we would be able to simplify that in one step by saying, oh, let's divide by the greatest common factor, which is 6, right? And that's going to scale it down to 1/3. So if you have a good grasp on factors, that helps you simplify fractions. So that's where you're going to use it most in math. But there are times when you've got like, oh, there are 54 oranges and 32 grapefruits and 29 bananas. And how many, gift baskets can I make with these fruit for the most people, having the same amount in each? Well, it's not something you see a ton, but you do see it in 6th grade math. You do see it whenever you're dealing with fractions, and New York State does tell us we have to do it. So, all of the above. That was really funny. Okay. Anyway, all right, let's do another one. Maybe if this board wants to erase for me. Okay, so the next one, let's do 4 and 7. This will take you probably a good 10 minutes. Well, I'm sorry, viewers, you missed us breaking out into song. But anyway, we do have the factors of 4 hopefully done. It's 1 times 4 and 2 times. That was tough. All right. How about 7? Don't tell me any decimals. Yes.
1/7.
1 and 7. Yeah. So, are there any others? Nope. We're only looking at whole numbers. All right. So, common factors here. Everybody? 1 and only 1. So the GCF is. Oh, I forgot to do the triangles in the other example. So the GCF of 4 and 7 is 1. Now, does anyone know the fancy math word that we call a number that only has 1 and itself as a factor? Giada's going to give it a try. Jasmine's upset.
I go a prime number.
A prime number, very good. We call any number that just has itself in one a prime, or as factors, a prime number. Does anyone know what we call all the other numbers that have multiple factors other than just one in itself? Begins with a C. Jasmine?
Compatible numbers?
Close. She said compatible. Not composer. Composite. Did I spell that right?
But it's a composite.
Okay. I'm having one of those moments where I'm not sure if I spelled something. Okay. Everybody in my class is doing a little more talking than I prefer. All right. So if, again, prime numbers only have one in itself, composite numbers have multiple factors other than one and itself. So tonight, for homework, you guys have a worksheet. So if everybody could take a peek at that worksheet, please. All right. So it is easy homework. Your worksheet looks like this. It says, find the GCF and show your work. Make sure to circle all the common factors and place a triangle over the GCF. I just couldn't see it. What? Okay. Yeah, we'll go over that in a sec. So I'm going to end this YouTube video. Thank you for watching. If you made it all the way through the video, congratulations. And I hope that you have a math magical day.